In this section, we'll look at addition and multiplication in other bases. First, a quick review that'll lead us to this fact down here. I'd like to convert these three numbers into base 10. Let's start with this one, 1 to base 4. The way this works is you take each digit and multiply it by its place value. So this 1 is in the 4's place, and this 2 is in the 1's place. So that would be 1 times 4 to the first plus 2 times 4 to the 0. Or you could just write 1 times 4 plus 2 times 1. Where again, this 1 here refers to this 1 here. It's in the 4's place. And this 2 refers to this 2 here, and it's in the 1's place. When you simplify this, this is 4 and this is 2. And therefore, the answer is 6. And we can say, well, this is base 10. So 1 to base 4 is equivalent to 6, or 6 base 10. What happens if we do this process but with a single digit, like 4 base 7 and 5 base 7? I'll start with this one here. 4 base 7, well, this 4 is in the 1's place, so I could write that as it's the digit 4 times 7 to the 0, which is really 4 times 1, and you get 4, which is 4 base 10. If we do the same thing for 5 base 7, it'll be very similar to this. The 5 is in the 1's place, so this is 5 times 7 to the 0, which is 5 times 1, or simply 5 base 10. Here is the observation that you can make. If you have a single digit and you're going from a smaller base up to base 10, the digit remains the same. So this 4 is still a 4 over here, and this 5 is still a 5 over here. This would be true for any base that's less than 10, provided that you're working with one digit. For example, you could say, well, what about 8 base 9? Is this going to be equal to 8 base 10? And the answer is yes. And that's because the 8 is in the 1's place, and 8 times 1 is still 8, but now we're in base 10. I'll state this as a fact. When converting a single digit from a smaller base to base 10, the digit remains the same, and that's the end of this fact. The digit remains the same. We will use this fact in a couple of the computations later in this section. Okay, so here in example 1, I'd like to add the following base 10 numbers. So for emphasis, I think I'll say this is 12 base 10 and 23 base 10. Now, I know we know how to do this, but we'll use this process as a guide when we start adding in a different base. So I'll note that the 2 and 3 are in the 1's place, and this 1 and 2 are in the 10's place. And the way this process of addition works is you add the digits that are in the common bases. So to start with, we have 2 and 3, and that adds to 5. No problems there. So then we go over to the 10's place and treat this as just a 1 and a 2, and when you add those, you get 3. No problems there either. And the answer is, no surprise, 35, or if you'd like, 35 base 10. Now, what if we switched the problem up just a little bit? How about if we instead added 1 to base 4 to 2, 3 base 4? Now, this is a very different problem. I still want to add, but now here we're working in a different base. One important thing to point out is when you're working in base 4 and you're adding digits together, you can only use 0, 1, 2, and 3, and nothing else. So let's see if anything different happens in this process here as compared to this. Now the process is you add the digits that are in the 1's place together, and then you add the digits that are in the 4's place together. So we'll start with the 1's. So we have 2 base 4 added to 3 base 4, and 2 plus 3 is 5. So already we have an issue. You're only allowed to use 0, 1, 2, 3, and 4, and when you add these two, you get 5, which isn't allowed. What I'm going to do is a little bit of work off to the side to figure out some way around this. So here's what we're trying to do. We have 2 base 4, and to that we're adding 3 base 4. And 2 plus 3 is 5, which is not in base 4. It turns out that this 2 base 4 and 3 base 4 is actually equal to 2 base 10 plus 3 base 10. Now, why is this true? This is true because of the fact that is on the previous page. 2 base 4 is equal to 2 base 10. If it's a single digit and you go up from base 4 to base 10, the digit remains the same. Same thing for 3 base 4. That's equal to 3 base 10 for the same reason. So when it comes to adding these digits together, you can really treat them as base 10 digits, and then 2 plus 3 is 5, and that's in base 10, and there's no issue. So 2 base 4 plus 3 base 4, it's 5, but here you can consider it as a base 10 number. So if we add these, it's equal to 5 base 10. What I want to do now is convert 5 base 10 back into something that is in base 4. So that's like the second step here. How do I make 5 base 10 something in base 4? This is what we did in the previous lesson. The trick is you want to split apart 5 by using powers of 4. And I think the simplest way to do that is to use 4 plus 1. From here, I can see, oh, here's the 1's place, and here's the 4's place. To make that really explicit, you can write this as 4 to the first and put a 1 in front of it. So you can write this as 1 times 4 to the first, plus, and you can treat this as 1 times 4 to the 0 power. And the second you do this, you can now read what the base 4 digit is. That's equivalent to 5 base 10. You can use this digit here and this digit here. In fact, the answer is 1, 1 base 4. And that 1 and 1 come from this 1 and this 1 here. So it's a long way to go, but to add these, you can treat them as base 10 numbers and then convert that base 10 number to something back in base 4. This 1 is in the 1's place, and we'll carry this 1 in the 10's place over to the 10's place. So what I'll do is I'll put a 1 here, provided that I carry the other 1 over to the 10's place. To complete this problem, I now have to add 1 and 2, and then the 1 that we carried. Now the sum is 4, which is an issue, so again, I'm going to do some work off to the side to figure out, well, what digit or digits should go here. So writing this process over here, we are taking 1, which is in base 4, and we're going to add 1 base 4, and then 2 base 4. That's 1 plus 1 plus 2, all base 4. Now, you can treat these all as a base 10 number. So you can say, oh, well, that's really the same thing as 1 base 10 plus 1 base 10 plus 2 base 10. And if you add those together, no problem. It's 1 plus 1 plus 2, which is 4, which is in base 10. So the sum of these is equivalent to 4 base 10. However, you want to convert that back to base 4 and then write that number here. So if we have 4 base 10, how can I write that as a base 4 number? Well, you can write 4 as 4 plus 0. I'll treat this as 4 to the first and put a 1 in front of it, and then I'll put a 4 to the 0 after this 0 here. So 4 base 10, it's really equal to 1 times 4 to the first. That's what this thing is equal to, plus 0 times 4 to the 0, which is the same thing as 0. 4 base 10 is equivalent to 1, 0 base 4. And that 1 and that 0, they come from this 1 and this 0. So when you add 1, 1, and 2 in base 4, the result is going to be 1, 0, which I will put here. So ultimately, this process is similar to this process, but the issue is you might have to convert from base 4 to base 10 and then back to base 4 to figure out what values to put over here. Let's try this again in another example. So in example 2, I'd like to add these base 5 numbers. So 3, 2, 3 base 5 and 4, 4, 2 base 5. Now remember, in base 5, we are only allowed to use 0, 1, 2, 3, and 4. Here's the 1's place, here's the 5's place, and here's the 25's place. We start by adding the 1's, then the 5's, then the 25's, and we write their corresponding digits down here. Okay, so we start with 3 base 5 and 2 base 5, and when we add those, well, we already have a problem. I mean, this is equal to 5, and you're not allowed to put a 5 here. So I'll do some work off to the side to figure out, well, what am I going to do with this spot? Something is going to carry how much stuff? So this is, we have 3 base 5 added to 2 base 5. We've done this a couple of times now. What we can say is, well, this is really 3 base 10 plus 2 base 10. Why not just put a 5 here? I'll say, okay, I know this is really equal to 5, but that's really in base 10. I now have to take this 5, which is in base 10, and convert that back to base 5. Now, how do we do that? We want to write 5 as a sum using powers of 5. And the way we can do this is by writing 5 as 5 plus 0. So here I have 5 base 10 is equal to, so this is really 5 to the first, and I'll put the digit 1 in front of it. So that's 1 times 5 to the first, plus, this is the ones place, so I'll put 0 times 5 to the 0 power here. So 5 base 10 is equivalent to 1, 0, base 5. And that 1 and that 0 come from this 1 and this 0. That's what we put down here. I put down the 0, but I carry the 1 over to the 5's place. So this becomes 0, and I carry the 1. Next, we want to add in the tens place 1, 2, and 4, which, okay, I mean, that's really equal to 7, which is greater than 5, so I have to do some scratch work off to the side. So let's see what we have. We have 1 base 5, to that we're adding 2 base 5, and then 4 base 5. And if we add these up, we get 4, 5, 6, 7, and I can treat that as a base 10 number. So that's really 7 base 10. I now want to take 7 base 10 and convert that back to base 5. So to split up 7 by using a base of 5, I think the simplest way to do that is to use 5 and 2. So really this is the 5 to the first place, and it has a digit 1 in front of it. And here's the ones place, and I can put a 5 to the 0 after it. So this is really 7 base 10 is equal to 1 times 5 to the first plus 2 times 5 to the power of 0. By doing this, I can say that 7 base 10 is 1, 2 base 5, where that 1 and the 2 are coming from the digit in the ones and the 5's place. Okay, great. So I'll put the 2 here and carry the 1 over. So I'll put 2 here and carry over the 1. We are in our last place value, the 5 squared, or the 25's place. I'll add these up and see if we have to convert. Okay, we're going to have to. This is 4, 3, and 1. That's 8. All right, so doing this work down at the bottom, we're taking 1, which is in base 5. We're adding 3 base 5 and 4 base 5. I can treat those all as base 10 numbers. 1 plus 3 plus 4 is 8, and now this is base 10. I want to take this base 10 number and convert it back into base 5. So how do I split 8 apart? Well, that is 5 plus 3 this time. And here, I'll put the digit 1 in the 5's place. And after the 3, I'll put 5 to the 0 for the 1's place. And this means the answer is 1, 3 base 5, where the 1 and the 3 are the digits that come from this place and this place. So I can place that right here. This is 1, 3. So here's the answer. 3, 2, 3 base 5 add to 4, 4, 2 base 5 is 1, 3, 2, 0 base 5. In example 3, we're going to solve these two multiplication problems. Ultimately, I'd like to understand how to multiply in base 6, but to understand how it works, let's first do this problem as a base 10 problem. That is, what is 25 base 10 times 3 base 10? It's good to go over the procedure because the procedure will be similar for what we do down here. So the process is, you take this 3, which is in the ones place, and you multiply it to this 5, which is also in the ones place, and you get 15. You leave the 5 here, and you carry the extra, the 1, over, and you put it above the 2 in the tens place. We then do 3 times 2, which is 6, but then we add this 1 up here to give us 7. So no surprise, the answer is in fact 75, or 75 base 10. But what if we look at this question here as a base 6 problem? Now the question makes sense because in base 6, you can only use the digits 0 through 5, and that's all that appears over here. We'd start by taking this 3 in the ones place and multiplying it to this 5 in the ones place. But the issue is, if you multiply these two things together, we get something that is greater than 6. So how do we deal with that? And just like with addition, we're going to think about that work off to the side. So what we're trying to do is, well, what is 5 base 6 multiplied to 3 base 6? When we were working with addition, what we did is we changed the base 6 numbers to base 10 numbers. And that's exactly what we're going to do here. 5 base 6 is the same thing as 5 base 10. And 3 base 6 is the same thing as 3 base 10. So I'm first going to say, well, this is 5 base 10 times 3 base 10. And at this point, I'd say, I know if we multiplied those two base 10 numbers together, you get 15, and 15 is in base 10. No surprise. But to write that down here, I need to express it as a base 6 number. So how do we convert 15 base 10 into something that is base 6? Okay, so we need to use powers of 6 in order to do this. And in fact, the closest that you can get to 15 by counting with 6s is 12. In fact, if you multiply 6 by 2, it gives you 12. It doesn't quite get you to 15, but you have to add 3 more. This pretty much takes us to the value for 15 base 10 converted to base 6. The reason is, I can think of this as 6 to the first power, and I can put 6 to the 0 after the 3. Therefore, the answer is 2, 3 base 6, where the 2 and the 3 come from this 2 and this 3. So 15 base 10 is 2, 3 base 6. That means I put the 3 down here, and I carry the 2. So I'll put a 3 here and carry the 2. The next step is to take this 3 and multiply it to this 2, and then add this 2 after it. And as before, it looks like we're going to get a number that is greater than 6. So I'm going to do some scratch work off to the side. So what we are doing is we are taking, we're taking 3, which is base 6. We're multiplying it to 2, which is also in base 6. And then we're adding 2 base 6 to that. Now, all of these are in base 6, but you can really think of them as base 10 numbers. So this is really 3 base 10 times 2 base 10 plus 2 base 10. Or simply 3 times 2, which is 6, plus 2, which is 8 base 10. I now want to take this base 10 number and convert it to base 6. So to split this up, 8 is 6 plus 2. If I call this 6 to the first, I can put a 1 in front of it. And then here I'll add this 6 to the 0 after the 2. And therefore, if we have 8 base 10, that is equal to 1, 2 base 6. And the 1 and the 2 came from this 1 and this 2. And then I'll put that right here. So we have 1, 2 base 6. So 3 base 6 times 2, 5 base 6 is equal to 1, 2, 3 base 6. In example 4, I'd like to add the following times together. 4 hours, 32 minutes, and 57 seconds to 3 hours, 46 minutes, and 35 seconds. All right, so I guess to do so, we could add the seconds, add the minutes, and then add the hours, and I suppose we're done. So here if we add the seconds, if I combine 57 and 35, I get 92, and I'll just put S for seconds, or maybe you could just put, SEC like that. If we add the minutes together, okay, that's going to be 78 78, no problems there, 78, and I'll put MIN for minutes. And then if we add the hours, that is a total of 7 hours, and I'll just put HRS like that. And there we go, 7 hours, 78 minutes, and 92 seconds. However, it says, can you simplify the answer so there's no more than 59 minutes and 59 seconds? So this really is not an acceptable answer. It's probably not the most obvious way to state the total duration of time. Let's start with this 92 seconds. The thing is, we can break this up by factoring out some number of minutes, since it's more than 60. In fact, you can treat this as a base 60 number. This will kind of look a lot like what we did in the previous examples in this section. I'm going to do some scratch work off to the side. We have 92 seconds, but how can I split this apart using the number 60? Well, 92 is 60 seconds plus 32 seconds. But it turns out that 60 seconds is equivalent to 1 minute. So we can really say, oh, okay, this is 92 seconds equaling 1 minute and 32 seconds. Essentially, we can drop this down to 32, provided that we add 1 minute over here to go from 78 up to 79. So this was not correct. This was no good in terms of being simplified. But we can say, oh, really, it should be 7 hours, 79 minutes, and 32 seconds. Now there's no problem. But again, now we have 79 minutes. There's some number of hours that can be factored out of here, and so I'll do some scratch work off to the side. We could really treat this like a base 60 number. We have 79 minutes. How can I split that up using 60? Well, it's equal to 60 minutes plus 19 minutes. And 60 minutes is the same thing as 1 hour. And therefore, I can drop this down to 19, provided that I carry the hour over here to make it 8 hours instead of 7. So again, this was not correct. This was no good for a simplified answer. But I can say, oh, it should have been 8 hours, provided that instead of 79 minutes, we say 19 minutes. And then instead of the original 92 seconds, we just stick with 32 seconds. We've now completed what was asked for in this problem. Add the times together, but then make sure your minutes and seconds are not greater than 59 each.